वेलकम टू एनसीईआरटी चैनल। तो इस क्वेश्चन में आप देखिए कि जो नेक्स्ट क्वेश्चन है, टॉपिक अभी इलेक्ट्रोस्टैट का ही चल रहा है। इसमें क्या है कि इनफिनाइट नंबर ऑफ पॉइंट चार्जेस ईच कैरिंग 1 माइक्रोकूलम चार्ज आर प्लेस्ड अलोंग द वाई एक्सिस एट वाई इज इक्वल टू। तो ये वाई एक्सिस पे रखा गया है, वाई इज इक्वल टू 1 मीटर, 2 मीटर, 4 मीटर, 8 मीटर। लाइक वाइज चार्जेस को रखा गया है और इनफिनाइट नंबर ऑफ पॉइंट चार्जेस जिसका चार्ज वैल्यू क्या है, 1 माइक्रोकूलम। The total force on a 1 coulomb point charge placed at the origin is x into। तो एक चार्ज है जिसको कि ओरिजिन पर रख दिया गया है और अदर सारे चार्जेस को y इक्वल 1 मीटर, 2 मीटर, 4 मीटर, 8 मीटर करके रखा गया है यहाँ पे। अब इस पे टोटल फोर्स जो लग रहा है 1 कूलम्ब के चार्जेस पे, वो लग रहा है आपको ये x इंटू 10⁻³ न्यूटन। तो फाइंड द वैल्यू ऑफ x एंड हियर इट इज नियरेस्ट ग्रेटेस्ट इंटीजर। So this is the question asking that integer kind of question, J main it is. So you know that it is 5 question will be there out of 10 question will be integer type on. So let's see the how to start with this question. That it is given on y-axis that I am placing here that charges accordingly. This is we are assuming that this is the y-axis here and origin is here. It is this is the origin position where 1 coulomb charge is placed. Next we have one. Next we have one. It is then we have two. Then we have three, and then we have four. Likewise, we have the till infinity. It is. So this is the thing it is given to you that 1 coulomb. Then the charges which is placed infinite numbers are the charges at 1 meter. Then we have 2 meter. Then we have 4 meter. So this is next charges is at 4 meter, then next charges will be at 8 meter. Likewise the charges is kept here. So first is 1 meter, then it is 2 meter, then it is 4 meter, then it is 8 meter. Likewise the charges till infinity it is placed here. So you can see here that if I'll find the force between the charges which are placed here to up to infinity it is. So the charges which are placed 1, 2, 4, 8 meter, likewise the charges that is 1 microcoulomb, and another charge 1 coulomb is at placed at the origin. So here it is 1 microcoulomb, here also 1 microcoulomb, here also 1 microcoulomb, here also 1 microcoulomb. So if you find the total force acting on the this charge which is kept at the origin पे जो चार्ज रखा हुआ है उस पे नेट फोर्स क्या लगेगा इन सब charges के कारण से, that you can apply superposition theorem. It is, we know that it is vector sum of all the forces because force is a vector quantity. So you can add over here net force will be vector sum. I am calculating here magnitude only, and that magnitude will be this is between the 1 coulomb and 1 microcoulomb, which is very near to it is. So it is k q1 and one charge it is q2. So k q1 q2 divided by this distance we are having r1. Let's suppose this I am considering here it is r1. Then this distance we are considering here it is r2, and this distance from origin it is this is r3. Likewise we have, so this is r1 square, then we have k q1 and then q3. Here it is, this is q1, this is it is q1, it is q2, it is q3, it is q4. Likewise the charges we have. So it is first q1 is fixed here, q2, and then we have r1, then we have k q1 q3, then it is r2 square. Similarly we can write here then k q1 q4 and then r3 square, and so on it will be added. So easily we can calculate. This question is not that much difficult, just now calculation only. How we can calculate, let's see it is. So k value, then 1 microcoulomb, here we have this k value, and this microcoulomb I'm taking 10 to the power minus 6 outside it is bracket, and then it is kept at 1 meter. First charge is kept at 1 meter. So, and it will be 1 divided by 1 of a square. Then the second charge is kept at 2 meters. So it will be, again, it will be 1 by 2 square. Again, next charge will be at 1 divided by 4 square. And likewise, the charges will be till infinity we can write here. So this is the thing we can simplify and we'll get the result here it is. So how you can get K value? We know that it is SI unit is 9 into 10 to the power of 9. And then we have 10 to the power of minus 6. And then this is something like GP we are having. GP is 1. This GP is, it is having this kind of GP 1 plus 1 by 4 plus this is 1 by 16. So likewise, it will go to infinity. So how you can add this? We know for this kind of S infinity of GP, it is A by 1 minus of R, where A is the first term and R is the common ratio. That is the thing you can write over here. So what is the first term here? We have 1 is the first term and common ratio is 1 by 4. So it is easily, you can calculate now, it is 9 into 10 to the power of minus 6 will get a cut here it is. So it is 3. And then finally you just write down this, this is 1 divided by 1 minus of 1 by 4. So this result we are getting here 4 minus 1, it is 3 and 4 will go in numerator. So 4 will go in numerator. So it is 4 into that. We are having this value as 4 minus 1. So it will be, it is 9 into 10 to the power 3. Then result here, it is 4 minus 1 is 3 and 4 will go in numerator. So it is 4 by 3. So finally, we are having this result. It is, this is 3. So it will be 12 into 10 to the power of 3. This is the SI unit of force. Here it will be Newton. So you can compare with the option. Option is not given here. It is written X into 10 to the power 3. So what is the value of X we are getting here? So this is the value of X we are getting. So this will be X. So in this question, the answer should be X. X will be integer value. It will be 12. So 12 will be the answer, I hope. So I hope it is clear that how we can find the forces between the charges, and one charge is fixed here and the other charges are infinite distribution. So you can apply the principle of superposition theorem over there, and thus just only that infinite summation of GP you can write over here, and this is that easy, that much easy you can get there. I hope it is clear. Thank you.